Hi everyone, I'm Isiki from FKE UTHM. So in this video, we are going to solve for question number 4. So given the following, so you have 3 mediums, okay? Each medium, they have different properties, okay? So sigma is the conductivity, okay? And the mu is the permeability and the epsilon is the permittivity, okay? So you need to identify, okay, the first question, which one of them is a lossy medium, okay? And you have to justify your answer. So before you determine which one is the lossy medium, you must recall back what kind of medium do we have, okay? So we have lossy, okay? And then we have lossless, and then we have free space, right? Okay, and then we have a good conductor. Okay, so these are the 4 mediums that we are dealing with in the chapter 4. So for lossy, what is the property? So for lossy, the conductivity, okay, is not 0. Okay, and it will have epsilon r value and it will have the mu r value. Okay, so for lossless, okay, so for lossless, the sigma is equals to 0, okay, and it has the epsilon r and it also has the mu r values. And for the free space, okay, free space, your conductivity is also 0, and you don't have the epsilon r, you don't have the mu r because it's free space, okay. And for the good conductor, okay, this one is very big, very big, okay, approximate to infinity, okay, and this is equals to epsilon naught, okay, that you don't have epsilon r but you have the mu r, okay. So this is the properties, okay, of the mediums. Okay, so now we need to determine which of it is the lossy, okay. So you can look at this one, lossy. Okay, so for lossy, the conductivity is not 0. Okay, so means that this is not possible, okay, to be a lossy mediums, right? Because the conductivity is 0. So now you have this and this. Okay, so one is a very huge, very big conductivity. Okay, very big conductivity. So this is possible a conductor. This is possible a conductor. So medium 1, okay, medium 1 will be your, okay, lossy medium. So you have to explain and justify why you say so. Okay, so for this one, okay, you can mention for lossy medium, okay, the conductivity is not equal to 0. And the epsilon is equals to epsilon r, epsilon naught. Okay, so you see you have an epsilon r. Okay, and for the mu, it is the mu r and mu naught. Okay, so in this case, this is okay. Alright, this is okay because most of the material they are not magnetic material. So most of the time, this one mu r is equals to 1. Okay, so for lossy medium, so these criteria is fulfilled. Okay, so say medium 1 has fulfilled the criteria. Okay, can just mention that it fulfilled the criteria. So medium 1 is medium 1. Okay, right. Okay, medium 1 has fulfilled the criteria. Okay, so this is question A. Okay, question B, assuming a given frequency f, identify which medium has the smallest skin depth. Okay, so skin depth is this one. Okay, if you remember skin depth, and explain why it is the most suitable material for shielding. Okay, so here you have to assume f. Okay, you have to assume your own frequency. Can be 100 megahertz, can be 200 megahertz. You make your own assumptions. Okay, so everyone you will have different f. Okay, so what is the skin depth equations? Okay, for the skin depth, okay, it is equals to 1 over, if you remember, pi f sigma and mu. Okay, so you have three mediums, okay, three mediums. You want the skin depth to be smaller. This thing you want smaller, so this part, okay, it must be bigger. Okay, how to make it bigger? So there are so many components, okay. Pi, F is fixed. Pi and F is fixed because F you can assume yourself. And for this conductivity, you can compare all these medium. Which one of them has the largest value? Medium 2, obviously. So only when the sigma is represented by the properties of medium 2, 58 mega, okay, this one will become very big. This one, you see, for all the things, for all the mu, they are the same. Okay, so the key point that making a medium to have smaller skin depth is the conductivity. Okay, so here we will choose medium 2. Okay, because it's asking which medium has the smaller skin depth. So you can say that this is medium 2 will have smallest skin depth. Okay, answer the question first. Okay, and then, okay, explain why it is the most suitable material for electromagnetic shielding. Okay, so here you have to explain why. Okay, skin depth. First of all, what's the meaning of skin depth? Skin depth is the thickness that the electromagnetic wave propagate and its amplitude will drop and left 37%. Okay, so this is your electromagnetic wave, okay, when it travel to the mediums. So initially, the amplitude is very high, but once it crosses the mediums, amplitude will drop significantly. Okay, so when the skin depth is very thin in a medium, it means that very fast, okay, this electromagnetic wave energy will drop. So this is the skin depth. The point that it dropped until 37% of amplitude of the original electromagnetic wave. Okay, so the thinner it is, the better it is used for shielding, because you just need to have a very thin material. Okay, it can attenuate. It can attenuate the electromagnetic wave. Okay, so here you have to explain. Okay, so when the electromagnetic wave travel in medium 2, okay, its amplitude will drop significantly after a thin thickness. Okay, after a thin thickness of skin depth. Okay, so this one you can. So it is best for shielding. Okay, best for shielding. You can explain by using this way. Alright, we look at question C. So refer to medium 1. Okay, medium 1. Okay, we know medium 1 is lossy mediums. Okay. Okay, where the electromagnetic wave operate at frequency 100 megahertz. Determine the following parameter: attenuation constant and phase constant. So this one you have to use the equations for lossy mediums, right? So for lossy mediums, what will be the attenuation constant formulas? Okay, so you have omega, right? Then you have a big square root (1 plus sigma over, right, and then square root minus 1. Okay, so this one is your attenuation constant. So we can continue 2 pi f. So what is f? F is 100 megahertz. So you put in the values. Okay, put in all the values. So for this, you have this one. Okay, because there is no mu r, and this is equals to 80 epsilon not over 2. Okay, so you have 1 plus sigma. So sigma is equals to 5 mu. Okay, over, okay, 2 by 100 mega. Okay, and then 80 epsilon naught, right? Okay, and then minus 1. Okay, you can do the calculations. Okay, so you get this one. So I think if you press calculator, right, okay, to get this one is very difficult unless you insert all of it together in your calculations, because this part is too small. Okay, if you split it, okay, in your calculator, in your calculations, this one you might cancel out. Okay, so press it as a whole so that you can get this one. Okay, so press it as a whole, right? Okay, so now we continue the calculations. So you have this. Okay, square answer and then multiply. Okay, so you have 1.05 times 10 power negative 4. Okay, so this is your alpha, and for the beta, okay, is plus 1. This one is plus 1. Okay, so you can use back the same equations. Okay, mega, right? So over here you have 4.45 times 10 power negative 16, and here we become 2 because it is plus 1, plus 1, so it will become 2. You can write down the equations. Okay, so if you do it, 4.45, okay, square root, okay, so it's 18.74, okay, radian per second. Okay, and this is nipple. Okay, right, so this is your beta. Right, sorry, this one should be per meter, and this one is also per meter. Okay, so alpha beta, and then for the question number 3 is the wave velocity, the u, the u, wave velocity. So the wave velocity is equals to u equals to omega over beta. Okay, so this is 2 pi 100 megahertz. Okay, 2 pi f over the beta. Beta is 18.74. Okay, so you can calculate the answer. So 2 pi 18.74. So you have 33.53 mega meter per second. Okay, so this is the speed. Okay, intrinsic impedance. Okay, intrinsic impedance. Okay, so for the intrinsic impedance, you have to use this formula. So you have J omega mu divide sigma plus J omega epsilon. Okay, so this is the formula to use. So you have J, so you put this 2 pi omega, okay, F, and this is the mu naught. Okay, and the sigma is I forget the sigma. What's the sigma value? The sigma value is 5 mu, okay, plus J, okay, so you have this one, 100 mega, and 80 epsilon naught. Okay, so this one you must change your calculator mode, okay, to complex, okay, to complex, and then you can insert this one. So 2 pi multiply 100 mega multiply mu I, okay, plus I. Okay, so you have your answer 1774.07, and the angle is 6.43, okay, in degree. Okay, you can make your angle in radian. Okay, it's fine. So now when want to simplify, this one is 1774 square root 1774.07. So you have 42.12, okay, and for the angle you divide with 2, so is 3.22, okay, degree. So this is your impedance. Okay, so for question 5, you have to find the electric field and magnetic field equation. Assume that the amplitude is 10 for the electric field, okay, and the electric field is in the y directions, and the electromagnetic wave is propagating in the z directions. Okay, so first of all, we have to write out what is the general formulas for electric field. Okay, so this is for the medium 1, okay. Okay, we refer to the medium 1. Okay, so you will have amplitude, right? And then you have an exponent term, alpha, and this one depends on the wave propagation. Okay, wave is propagating in the z direction, so negative z. Okay, and doesn't specify whether it is sine or cos, so it's up to you. You can put sine. Okay, so you have omega t minus beta z. Okay, and according to the questions, the electric field is y directions. Okay, y directions. Okay, so now you can plug in the value that you know. Okay, for example, the amplitude is 10, right? 10. Okay, and for the alpha is what? Alpha, so 1.05. Okay, so 1.05 times 10 negative 4 z. Okay, then you have sine. So for the omega, so it's 2 pi f. Okay, so you 2 pi f, so is 628.32 mega t. Okay, beta is how much? Beta is 18.74 z, right? And y directions. Okay, y directions. Okay, so this is your electric field equations. And for the magnetic field, it's the same thing, right? But you need to determine what is the magnetic field, the amplitude. Okay, and what is the directions. Okay, so for the amplitude, you can use this relationship. Right, so your electric field amplitude is 10, and your eta, okay, your intrinsic impedance is 42.12 and the angle is 3.22 degree. Okay, so your H is equals to 10 divide 42.12. Okay, is 0.24. Okay, and the angle is negative 3.22, because 0 minus 3.22. Okay, so as for the directions, you have to use this relationship. So this is y directions, and this is z directions. Okay, so your H will be negative x. Okay, H will be negative x. Okay, in order to get positive z. Okay, so now you put it into your formula for the magnetic field is 0.24. Okay, you have exponent negative 1.04 times 10 negative 4 z and sine 628.32 mega t, and beta is 18.774 z, and minus, okay, because this thing I want to put here and I change it to radian first. Okay, 3.22 times pi over, okay, I'm changing it to the radians, 0.056. Okay, so this is here. Okay, right, so this one is degree and this is radians. Radians. Okay, and what directions for the magnetic field is negative x directions. Negative x directions. Okay, so this is your magnetic field equations.